In this video, I'm going to show you how to build the most interesting, fun, yet simple Python project that you've ever seen. Now, I know that's saying a lot, but what we're going to do here is build an AI choose your own adventure game in under 100 lines of code. Now, I'm going to walk you through step by step, and I promise you, even if you're a beginner programmer, you're going to be able to follow along here, and you're going to have a fantastic project that is going to be a lot of fun to play with. Now, for those of you that just want to dive right into the code, I'll leave a timestamp down below, but I did want to mention that we're going to be doing this using an OpenAI GPT model and integrating that with an Apache Cassandra database. Recently, they added vector support, and that means we can actually inject real-time data and a memory buffer into our AI model. Really, really cool stuff. I know it seems complicated, but I promise I will break it down and it will be crystal clear. Now, let's dive into a quick demo of the project. So I'm going to run the code here. Quickly, though, I'll mention that a choose your own adventure game is a branching game where you have multiple different paths and kind of options that you can choose, and each choice affects the choice in the future, and eventually you're trying to go down the correct path. These were really popular back in the day when I was a kid, and I've built a bunch of hard-coded choose your own adventure games, but they can be really tedious to write out. So have a look at this. Welcome to Whispering Woods. It is said that the lost gem of serenity lies hidden in these woods. You must adventure deep into the depths of the forest to find it. Before we begin, what weapons would you like to take with you? Now notice I can choose any weapons I want here, different from a traditional choose your own adventure game. So go with maybe shield and axe. Okay. So I'm going to take those as my weapons. Very well, you've chosen a shield and axe. Now let us enter the Whispering Woods and begin your quest. Okay. Let's see what it says next. As you make your way through the forest, you come across a fork in the path. To the left lies a path of darkness, and to the right lies a path of light. Let's go light. That seems like the better option. Okay, let's see where it brings us. You have chosen the path of light. You continue down the path until you come to a clearing where a small cottage sits in the middle. As you approach, the door swings open and a mysterious figure beckons you inside. Will you enter? Yes, I will. Okay, let's see what we get here. And you step inside and find yourself in a cozy room with a warm fire burning in the corner. The mysterious figure greets you and tells you that the gem of serenity is hidden deep within the forest. He then offers you a choice. You can either go at it alone or with his help. Let's go alone. Now notice all the stuff you see here, I didn't write. This is being generated by the AI, okay? So keep that in mind. Very well, you decide to go in alone. Do you enter the cave or do you turn back? Enter the cave. I'm just trying to get it to a point where I either die or I find the stone, so you guys can see how this ends. You enter the cave. As you make your way through, you see a dragon. Do you want to sneak past or fight it? Let's fight the dragon. And you attempt to fight the dragon, but it proves too powerful for you. You are quickly defeated, and the dragon devours you whole. The end. There you go. So this whole thing that you saw was generated by AI in real time as I was typing it, and it uses memory. So what that means is it knows all of the choices I've made previously, so it can generate the next choice using contextual data. Really, really interesting, and I'm going to show you exactly how to build this. Now, let's just quickly compare that to a traditional choose your own adventure game. So this is some code I'm just going to quickly scroll through that would be a hard-coded version of that, where you need to actually manually enter every single path, every single option. You need to check for a specific string. You couldn't type what I typed, where you do like an exclamation point at the end, or you have a leading space, or you kind of do a weird answer to the question. You need to actually hard code all of this stuff out, as you can see in here. Whereas what we're going to do is just give a really detailed prompt that describes how the game should be played, and the AI is going to take over and handle all of it for us. So I promise we're going to get into the code, but stick with me here for a minute or two where I share with you some important information about how powerful what I'm going to show you actually is and how you can apply this outside of this simple tutorial. So when we think about LLMs and these language models like ChatGPT, they're very impactful. They can do a lot of really interesting stuff. And the main benefit to us as developers is that they can reason based on information. And a lot of times we'll want to take a model like this and use it in our application. We want to implement generative AI. Now, the main issue and bottleneck we're going to face here is that we don't really have a way, at least many people don't know a way, to inject real-time data into the model. Now, what that means is that the model can only reason based on the data it was trained on, right? If it was trained back in September 2021, like ChatGPT, it doesn't know up-to-date information, and it's going to give us kind of hallucinations where it's misrecalling things, it's giving us the wrong data, it doesn't know the answer to specific questions because it doesn't have the information to be able to answer what we're asking. Now, at the same time, these models have a very hard time remembering large chunks of information and recalling that data accurately. Go into a ChatGPT window, ask it a bunch of questions, then ask it, how many questions have I asked you? And you're going to see quite quickly it'll get that wrong a lot. Even ask it to recall previous questions or prompts that you've given to it. And again, it's going to hallucinate and it will give you a lot of wrong answers. So we as a developer need to mitigate that so that we can actually have a reliable generative AI tool that we can use and that can be production ready and user facing. How do we do that? Well, we need to essentially inject the data that we deem accurate and that we want the model to reason in the prompt, and then instruct the model to reason based on that information. Now, this is a technique known as RAG, or Retrieval Augmented Generation. Now, to go a step further, what you can actually do is use the model, ask it to tell you the information it needs, and then based on its response, retrieve the information, feed it into the model, and have it give you an accurate reply. This is a big thing. It's very trendy right now. Again, RAG, R-A-G. Anyways, in this tutorial, what I'm going to show you how to do is have a memory for our LLM. That means that we'll actually allow it to know all of the previous paths, all of the previous replies, so it can generate an accurate reply going forward for our Choose Your Own Adventure game. So now comes the question, how do we do all of that? Well, obviously, I'm going to show you here step by step, but to be able to provide real-time data to an LLM, we need to have a very, very fast database. And in this video, we're going to use a vector database provided from DataStax. I've actually teamed up with them for this video. They've sponsored it and provide a free vector database that you guys can use, and you'll see exactly why it's kind of the best tool for this type of application. Anyways, what is a vector database? Well, a vector database stores information as vectors in multi-dimensional space versus a tabular database, or like your typical kind of SQL database, right? This actually allows us to very, very quickly search for information because we're searching in a multi-dimensional vector space where we can compare vectors together very quickly relative to searching in an index database that can kind of get out of hand when it gets very, very large. At small scale, obviously none of this matters, but when you scale to the point where we're dealing with petabytes of data and we have all kinds of information we'd want our LLM to have access to, we need to be able to retrieve that information instantly, really, really fast, right? So we need to use a vectorized database to do that, or at least a very, very fast database, and this is the best one that I know of. I'm going to show you how to set that up. But again, the vector database stores data in a different representation. You can look it up. It's actually really interesting how it works. And it's kind of the ideal type of tool for something like an LLM and the type of application we're going to build. So as I was saying, what we need for this to work is a vectorized database that can store and retrieve information for us. Now for that, we're going to use the Astra Cassandra database, which is a fully managed service from DataStax, who is the sponsor of this video. So click the link in the description. You can sign up with them for free. You don't need credit card or anything like that. And we can make an instance of this database for free and everything will be handled for us. Typically, vector databases can be complicated to set up, but in this case, we just press like 1 or 2 buttons, fill in some info, and it will just create it for us and give us all the connection steps that I'll walk you through. All right, so once you've signed in, you should be brought to a page like this, and what we can do is go and click Create Database. Now, we're going to make a vector database, again, optimized for the AI application. Database name, call this whatever you want. I'm just going to call this Choose Your, if we could spell this correctly, Own Adventure. Looks like I need a language model to help me type. For the key space name, you can call this whatever you want. I'm just going to go with database. And then for the free tier, you just have one region. So just go with whatever the available one is. And then same thing, we're just going to go with Google Cloud. Or actually, I guess you can choose one of these different options, but I'm just going to use Google Cloud. Okay. We're going to create this database and it's automatically going to be handled for us. It's going to take a few minutes to provision and be set up. Once it's finished kind of being set up, then I will show you how we can connect to it. All right, so our database has been created. What we're going to do now is go over to connect, and we're going to download the appropriate authorization and kind of connection things that we need. So what we'll do is we'll follow along with a few steps that are actually down here. This is going to allow us to connect to the database and create a place where we'll store the memory for our LLM. Once we have all of that, we'll actually connect to OpenAI. We'll then generate the prompt and we'll start actually creating the game. It's going to take a little bit of time. Bear with me here. I promise this is worth it. Really, really cool application. Okay, so we're going to go from overview to connect. We're going to click on generate token. We're going to download the token details into the same directory where our Python script is. So you can see here, I'm in VS Code. You can open any editor you'd like. I've created a Python file, tutorial.py, and inside that same directory, very important, it's in the same directory, I've put my JSON file. Now, obviously, don't share that with people. I'm just showing it here. I'm going to delete the database afterwards. Okay. Next, we're going to go to get bundle. We're going to click on that. We're going to click on our region, and we're going to download the secret bundle again to the same directory where our Python file is. Okay. Now, next, we need to install a few things. But before we do that, we are actually going to create a virtual environment where our code is going to live, or where our dependencies are going to live. If you're unfamiliar with a virtual environment, this is an isolated container specifically for Python, where all of the Python packages related to a project are going to be stored. Very useful when you have a lot of different projects and dependencies. Anyways, what we're going to do here, if you're on Windows, is you're going to open up PowerShell. To do that, if you're in VS Code, you can go to the little plus button where the arrow is and just click on PowerShell. If that's not an option, you can go to the search bar and just type PowerShell, and you can just run the commands that I'm going to show you from there, as long as you're in the correct directory in PowerShell. Now, if you are on Mac or Linux, then what you're going to do is just open up a normal terminal environment, and I'll tell you the corresponding command that you need to run. So what we're going to do is we're going to say pip install virtual env. Now, this is what will allow us to actually create the virtual environment. If you're on Mac or Linux, try pip3 install virtual env. Now, I'm going to go ahead and run that. You can see I already have it installed. Okay, now that we have that, we're going to type virtual env and then the name of the environment we want to make. Now, typically, you'll just call this env. So I'm going to do env, and this should be the same command for Mac or Linux. Okay, so you see it created an env folder for us up here. Now what we're going to do is activate the virtual environment. Now, this is where the command will differ depending if you're on Mac or Linux. If you are on Windows, though, you're going to type /env/scripts/activate, okay? Go ahead and hit enter, and you're going to see a little kind of parenthesized env here, which means you're in the virtual environment. Now, if you're on Mac or Linux, you're going to type source, and then that same thing. So it's going to be /env/scripts/ if you do the slashes the right way, activate, okay? And that should activate the virtual environment for you. Now, to deactivate it, you can just type deactivate and you'll get out of it. But now that we're inside the virtual environment, I'm just going to make this half screen again, and we're going to follow along with the installation steps. So we're going to go here to Python because this is the driver we're using, and we're going to first start by installing the Cassandra driver. So I'm going to right click there and click on pip install Cassandra driver. This is going to take a second. Once it's finished, I'll be right back. All right, now while we're installing packages, there's a few more that we need to install. Let me make this full screen here. These don't come directly from that documentation, but what we're going to use is something known as LangChain, which is going to allow us to interface with OpenAI. So we're going to type pip install, again, inside of the virtual environment, and we're going to install Casio. We're going to install LangChain like that, OpenAI, and then tick. And it's actually not TikTok, although it looks like it, tick token, like that. Okay, so install these, Casio, LangChain, OpenAI, tick token, and that should give us all of the dependencies that we need. There might be one or two more, but I think that's pretty much it. Okay, so while those install, we're going to go back to half screen here, and we are going to now run the next steps here. So we already have this directory. We don't need that. We're just going to go and we're going to copy all of the code here, and we're going to paste this inside of our tutorial script. Once we have that, we can actually close this window, and we can start working from this. Okay, so what this is going to do here is connect us to the database. Now, we're going to modify this script slightly, but this is just going to essentially test the connection and make sure it's working properly. So all we need to do is we just need to go where all these files are, and we need to rename them to whatever they are actually named in our directory. So you can see here my cloud config, secure connect bundle, and this is named secure connect choose your own adventure.zip. Okay, that's correct. That's fine. We're going to scroll down. You can see this right here. This is not correct. We need to change this name of our JSON file, which is choose underscore your underscore, if we could do this correctly, own adventure, like that, and then token.json. Okay, once that's there, we're going to open up our terminal. From our virtual environment, we're going to run our Python script. So we're going to say Python, and then this is called tutorial.py. So I'm going to run that, and we're just going to make sure we get some output. If we get this output right here, or really anything that doesn't tell us an error occurred, we're good, and we have connected to our database. All right, so now that this is working, we're just going to clean up the code a little bit and start adding some stuff. So I'm just going to delete these comments here that we don't need. And I'm going to go and just delete this kind of row code because we're not going to use that either. Now I'm going to create two variables that we're going to fill in a second. The first is going to be the Astra underscore DB underscore key space. Okay, this is going to be whatever you named it when you were creating the database. So in this case, we called it database. We're then going to have another variable here, and this is going to be the OpenAI underscore API underscore key. And this is going to be our OpenAI API key, which we'll retrieve later on. Now, though, what I'd like to do is I want to connect to the Astra database or to the Cassandra Astra database, whatever you want to call it. And I want to initialize memory. So I'm going to show you how we create the memory. Then what we'll need to do is retrieve from memory and inject that into an OpenAI prompt. So we're going to write a fair amount of code here. I'll try my best to break it down step by step. Obviously, if I'm too slow for you, feel free to speed up the video. So what I'm going to do down here is say message underscore history is equal to Cassandra chat message history. Okay, and we're going to import this from above. So we're going to go up here to import, and we're going to have a few things that we need to import here. We're going to say from langchain dot memory import, and this is going to be Cassandra chat message history. Now, if you see me looking to the side, that's because I do have a cheat sheet open. I don't have all of this memorized, obviously, but I'm going to type it out with you so I can explain it line by line. Okay, so inside of message history, we're going to essentially initialize a place in our vector database where we're going to store the log of the chat history for this specific application. So we're going to say our session underscore ID is equal to, and you can make this literally anything you want. This is just a unique key that will allow you to retrieve the session later on. So if you actually wanted to store the progress of the Choose Your Own Adventure game, as long as you know what the session ID is and you don't clear the history, you can access this at any time. You'll see what I mean in a second. Next, we're going to say the session is equal to session, which is the connection to our vector database. We're then going to say the key space is equal to, because you can have multiple key spaces, the Astra DB key space, and then we're going to say TTL underscore seconds is equal to 3600. This stands for the time to live seconds, which means we are going to store all of this for a maximum of 60 minutes. If it hits 60 minutes, we're going to delete whatever was added inside of here automatically. We're then going to say message history dot clear. Now that's going to clear the message history, which is just going to delete all of it. That means every time we rerun this application, we'll get a new set of memory for the new instance of the game. All right, now that we've created message history, we're going to use a wrapper around this that will allow us to easily add to the message history. You'll see what I mean, but all of this is coming from LangChain. If you're unfamiliar with LangChain, this essentially allows us to set up pipelines for dealing with models like LLMs, language models, etc., and a bunch of other stuff like databases. You can see from langchain.memory, import this, and this is a wrapper around the vector database, right? And same thing with a bunch of the other stuff we're going to use. Now, actually, from the same import line here, sorry about the cut there, guys, we're going to import the conversation buffer memory like that. We're then going to come down here, and we're going to say that our Cass underscore buff underscore memory is equal to Cassandra, not chat message history. Why do I keep doing Cassandra? This is conversation buffer memory. And inside of here, we're going to have our memory underscore key. And you can make this equal to whatever you want, but I'm going to go with chat history. And you'll see where we use that in a second. And then I'm going to say my chat memory is equal to the message history. Now, this is going to make it easier for us to load this into the OpenAI prompt, which you're going to see in a second. All right, so we're actually almost there. Just bear with me here for a second. We're going to go back up here, and we're going to import a few things from LangChain again that we're going to use to interact with OpenAI. We're going to say from langchain.llms import, and this is going to be OpenAI because that's the one that we're going to use. You could use other ones as well. We're then going to say from langchain dot, and actually not dot, we're just going to say from langchain import LLM chain and the prompt template. Okay. We're going to go down here. We're going to initialize a connection with OpenAI. So we're going to say LLM is equal to OpenAI, and we're going to pass the OpenAI underscore API underscore key equal to the OpenAI API key. Okay, I think I spelled that correctly. I believe I did. So now we have our LLM. So we'll get this key in a second, but for now, we'll just write the code. Next, we're going to say LLM underscore chain is equal to LLM chain. And what we're going to do is connect this to our LLM. So we're going to say LLM is equal to LLM. We're then going to say prompt is equal to, and this is going to be a prompt, which you'll see in a second. And we're going to say our memory is equal to the Cassandra buffer memory. So what this is doing, LangChain, is just wrapping all the stuff that we need to do with a really easy to use API. I know it seems weird because like, where are you going to find all this information? But this is just right from the documentation. Okay, so that's kind of where I'm copying it from and how I've constructed this project. Now, one thing that we do need to do now is we need to make something known as a prompt template. Now, you may have seen this in some other videos of mine or some other applications, but the template is a way where we dynamically inject data into kind of ChatGPT or the LLM or the prompt, right? That's what we're doing. So I'm going to say prompt is equal to prompt template. For the prompt template, we specify the input variables that we're going to have, which is our dynamic or changing data. So we'll say input variables. Now, the first variable is going to be chat history, which matches with the name of our memory key, okay? So what we'll do, actually, let me just add the next one and then I'll explain this. Next, we're going to say human input. And then we're going to go here and we're going to say the template is equal to template. And we're going to define a template here. And we'll write this in a second. Okay, so the idea is that we're going to have input variables that we're going to pass into this template. You write the input variables like this, chat underscore history. Now, when I specify the input variables, what will happen is we'll have some value for these. We'll pass them into the template. And then when we make a prediction, we'll be using a template that contains this dynamic data. So if you go through step by step here, right, I have my LLM chain, which now we're going to use our prompt for, and we're using our buffer memory. The buffer memory key is chat history, meaning now when I use the LLM, it's going to take that memory and it's going to inject it inside of the prompt as the chat history key. It's then up to us to provide the human input. All right, we're almost there. Now let's fill in the template and we'll actually start making some predictions. Now I'm going to copy in the template. You can copy this from the link in the description. All of the code will be available there, but I'm not going to obviously type all of this out. And let's read through this template, okay? So what I've done is I've specified what it is that I want the AI to be kind of responding to or how I want it to act. Now, this template is fully customizable. You can change this to be whatever you want, and this is really going to be you defining the rules of your choose your own adventure story. So if I read through this here, it says, you are now the guide of a mystical journey in Whispering Woods. A traveler named Alara seeks the lost gem of serenity. You must navigate her through challenges, choices, and consequences, dynamically adapting the tale based on the traveler's decisions. Your goal is to create a branching narrative experience where each choice leads to a new path, ultimately determining Alara's fate. Here are some rules to follow. And this is where you're going to be specific and you're going to tell it, hey, I want you to ask this type of question. I want you to ask this first. I want you to do this. That's where you define the structure of the game. It is going to be random, but you can make it much more concrete if you make this prompt a lot more detailed. So rules, start by asking the player to choose some kind of weapons. You saw that. That's what it did when it asked me. Have a few paths that lead to success. Have some paths that lead to death. If the user dies, generate a response that explains the death and ends in the text, the end. I will search for this text to end the game. So you're telling with natural language, the AI model, how you want it to generate a game for you, which is really going to be the future of programming. Kind of a cool way to showcase that here. Anyways, here's the chat history. Use this to understand what to say next. Boom, provide the chat history. Here's the human input, and then the AI is going to generate a response for us. Hopefully that makes a bit of sense. But this is the template that we're now going to pass to the LLM, which will be ChatGPT. And now it's going to generate all of this stuff for the game for us. We don't need to manually code it like we would have here with like all these if statements and print statements and all that crap we'd have in a traditional game. We're almost there. What we need to do now is make a prediction. But before we can make a prediction, we need to have our OpenAI key. So let me open up that site and let me show you how we generate it. All right, so to generate your API key from OpenAI, you're going to go to platform.openai.com/account/API keys. You can find this pretty easily from the website by clicking over your name. If you click that, it will say view your API key. Anyways, we're going to take this URL. I'll leave this in the description, paste it in the browser, and we're going to go to create new secret. Now for this, I'm just going to go with game. It's going to create a secret key. Obviously, I will delete this after the video. You're going to copy the key, and we're just going to take that and paste that here. Okay, now we have our OpenAI API key. Now that we have that, we can start generating some predictions from our LLM. So to do that, we say LLM underscore chain dot predict like that. And then we pass to this the human underscore input equal to, and then whatever we want this to be. So in this case, let's just say start the game. Now what this will do is return a string to us. So we're going to say response is equal to that. And then we can print the response. Now notice that this human input variable matches with the input variable to my prompt template, and we could have many other variables if you wanted to add those. You just have to specify them here. Okay, so if I go here now and I run my code, so this is going to be python tutorial.py, we should just get the output that begins the game for us, and then I'll show you how we put this in a loop. Okay, it actually gives us an issue here. It says unknown key space database. So it's possible that I entered the wrong key space name. Let me have a look and I'll be right back. All right, so it looks like I spelled the key space name wrong, data BSE, hence why it wasn't appearing. So let's just go over here and change that to be the correct name. I'm sure you guys can spell better than I can, so you probably didn't have that issue. Anyways, let's clear and rerun this here. And let's finger cross and hope it gives us the output. Let's see. There you go. Welcome to Whispering Woods. You have come in search of the lost gem. Before you embark on your journey, you must choose a weapon. Will you take a sword, staff, bow, or axe? Boom. And you see, starts the game. Now what we want to do is put this in a loop and see that memory come into action where it starts generating us through the different paths. So let's go down here and let's set up a little bit of a while loop for us. So we're going to start by just saying choice is equal to, and we're just going to say start like that. We're going to say while true. Okay. And then what we're going to do is we're going to generate the response based on the choice. Now, the first choice, I'm just hard coding because I want the first thing the user sees to be some output from the AI. So we need to first just give it like a start prompt so it just generates that initial message, okay? We have that. We're then going to say choice is equal to input. And we're going to say your reply like that. However, before we do that, we're just going to look at the response. So we're going to print the response. I'm going to do .strip. Now I'm just going to strip it so it gets rid of any leading or trailing white spaces or new line characters because sometimes the AI generates those. We're going to print out the response, and then we're going to say if the end in response, then we're just going to break. Now the reason for that is, again, if we go look at our prompt, remember I have a rule here and it says, if you die, have the end and a period contained in the response. So now, if that's the case, right? So if the end is there, we're just going to break, which is going to end the game for the user. That's it. Now you can make this any search string you want, but that's what I told the bot to generate. So I'm going to look for that, and then we should be good. Hopefully this makes sense, this little while loop here, but this is just going to run the game infinitely until we win or until we die, essentially until the AI gives us the end. Okay, so let's go in here, zoom in a little bit, and let's try this. Python tutorial.py. Okay, it's going to take a second here. There's a little bit of latency. And it says, welcome to the Whispering Woods. What weapons will you choose? Let's go with axe and sword. Okay, we're going to dual wield here. Chosen axe and a sword. Good choice. You now must decide what path to take, left, right, or straight. Let's go left. Okay, you choose left. As you venture further down the path, you come across a large stone wall with a mysterious door. What will you do? Open the door. Now look at this, right? You can type anything you want here. Kick down the door, break the door, run away. Like, it's so dynamic because of the fact that we're using the AI, which is why I really love this project. Anyways, open the door. You open the door cautiously and find yourself in a dark and ancient chamber. As you explore the chamber, you find the chest containing the gem. You've succeeded, in your quest. The end. Boom, ends. Let's run it one more time. Okay. And by the way, if you want it to be longer, you could just write in the rules, you need to go down at least 10 paths or make 20 decisions before you reach the stone. So if you want to make it harder, you can just tell the AI, make it harder in the prompt, right? Okay, welcome to Whispering Woods. Let's bring a shield. Okay. And you have chosen shield. Which way do you go? Let's go left. Okay. And you enter the temple, find a large chest. You open the chest. Leave it. Okay, and let's see what we get here. You leave the chest and continue your journey. As you walk further down the path, you come across a bridge. Do you want to cross the bridge? Cross it. Okay, let's see what happens now. You cross the bridge and make your way to a cottage. As you approach the door, you hear a loud rumbling. Suddenly, a giant beast emerges. You must fight for your life. Do you use your shield or try to run away? Use the shield. So notice it's using a decision I made previously, the shield, in this decision, right? Which you can continue to prompt the AI in that main prompt to do. You raise your shield and prepare for battle. The beast charges at you, but your shield holds strong and you're able to fend off the attack. You defeated the beast. You found the lost gem. Congratulations, the end. Okay? Maybe not the most thrilling end to a story, but again, you need to instruct it with what you want in the prompt, which is really up to you guys. So with that said, that's going to start wrapping up the video here. That's all the code. Again, I'll make it all available from the link in the description, so you can just download it and fill in the few variables and files, and you'll just be good to go. And that is how you make an AI choose your own adventure game. I think this was a really, really cool project. I had a lot of fun building this. And I think if you guys adjust this prompt and really add some more rules and give this some more structure, you're going to get a really, really interesting game and a really cool project. Thanks again to DataStax for sponsoring this video. Such a pleasure to work with them and really a cool project that we were able to generate here. I hope you guys enjoyed and found some value. If you did, leave a like, subscribe, and I will see you in the next one.